Good morning, everyone. Welcome back to the last day of week 13. Okay, let's go over to our notes. Let's get this thing over with. All right, so solving and graphing linear inequalities. This is our unit 8. So very quickly, let's go through. Good morning, Ethan. No worries. We're going to look at our inequality symbols. We have less than. One of the tricks that I tell students is that if you are confusing less than with greater than, just look at this symbol. Doesn't that kind of look like an L that's just been slanted, right? It's like an L that tipped forward just a tiny bit. So here's our less than. And again, sign language, L, right? L, okay. So less than, greater than, here's the less than or equal to, and then here's greater than or equal to. Now, when solving linear inequalities, we follow all the same rules for solving linear equations, but with one major exception. If we multiply or divide by a negative number, we must flip the direction of the inequality symbol. That's the main ingredient here. So I have an example. It's a very quick example because I wanted you to see exactly what happens. So we have negative 4m divided by 12. Well, negative 4 times m divided by 12. So we say, oh yeah, I know how to solve for m. I just have to divide both sides by negative 4. When I divide both sides by negative 4, here's what happens. So I'm dividing by negative 4, which means this inequality symbol must flip direction. So negative 4m over negative 4 simply becomes m, right? That doesn't change. The math does not change, right? 12 divided by negative 4 is still negative 3. The math does not change. The only thing that actually changes here is the direction of our inequality symbol. So it goes from less than to greater than. Ta-da! And that's the main component here. So as long as you are multiplying or dividing by a negative number, you gotta flip the direction of the inequality symbol. Cool. Now that we've covered that, what we're going to do for each of these subsequent problems is we're going to solve them. That's the first thing. We're going to graph it on a number line, our solution. We're then going to express our solution in set builder notation, and we're going to express our solution in interval notation. Now you're probably thinking, never heard of it, right? Not a big deal. What I've provided to you here is a reference table just so that everything's nice and compact and put together and it's easy to say, oh, okay, I know exactly what we're talking about here. Okay, so I will go back and forth with referencing this table as we move through our very first problem. So our very first problem reads 3 times 2b minus 4 minus 16 is greater than 32. Naturally, all of you would say, oh, well, I'm just going to distribute 3. So you go ahead and you just distribute 3 to each term. So you have 6b minus 12 minus 16 is greater than 32. I love it. So far, so great. The next thing we're going to do here is we are actually going to combine like terms, right? We always clean up our equations, essentially. We always combine like terms before we move terms around. So negative 12 and a negative 16, well, that gives me a negative 28. So I have 6b minus 28 is greater than 32. My next step is to say, okay, well, I want to solve for b. So I need to move the 28 over to the 32 by using the opposite operation. So we're going to add 28 to both sides. That leaves me with 6b is greater than 60. Last step, I need to divide by 6 so that I can isolate b. Keep in mind that I'm dividing by a positive 6. So because I'm dividing by a positive 6, I do not need to flip the direction of the inequality symbol. So for part A, it asks us to solve. Here is the solution. B is greater than 10. The next thing we're going to do is we're actually going to graph this on a number line. So I'm going to go ahead and draw my number line here. Now what you're going to be surprised by is that I'm actually not going to write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ugh. No, what I'm actually going to do is to note that b is greater than 10, so I'm going to shift the number line so that 10 is right in the middle. Okay. Now, I want you to consider what this says. B is greater than 10. When you think B is greater than 10, you should think, okay, 11, 12, 13, 14, or you could be more specific, 10.1, 10.2, 10.3, 10.4, right? All of those numbers greater than 10. But what you can't say is that B is 10, right? You can't. The statement is B is greater than 10, which means we're not including 10. So let's look at a reference table so I can show you what I mean and how we denote that it's approaching but not including. Check it out. So here, notice B is greater than 10. Greater than implies open circle. And when we imply open circle, we're saying we're not including the value. Versus, if this statement said B is greater than or equal to 10, then we would be including the value. So notice we're not including the value versus if we had greater than or equal to, would be including the value. So what we're going to do is above the 10, I'm going to draw an open circle. I always like drawing it above the line so that it's visible. If you draw on the line itself, sometimes it's harder to see. So open circle on 10 because we're not including it. And then B is greater than 10. So we're thinking 11, 12, 13. We know, oh, okay, it's this direction. So we shade to the right. And there's our answer on a number line. Perfect. The next thing I'm actually going to introduce you to is something called interval notation. When you think of interval notation, I want you to think of an interval, lowest to highest, right? So lowest number to highest number. For instance, if you were going to get an A in this course, you would tell me you would need a 90 to 100, right? You would. You wouldn't say 100 to 90. Oh, I need 100 to 90. Like, wait, what? That's weird. No, you would say, I need a 90 to a 100. So those are that's your range of values. Lowest number to highest number. So we're going to do the same thing in this case when writing our interval. My advice is always look at the number line. Even if you aren't asked to draw a number line, you should draw a number line because a visual is going to help immensely. I don't know about you, but I am a visual person, and it helps me to deduce exactly what my interval notation would be based on the visual that I have. So I want you to do the same thing, okay? So here's our number line. And now we can write our interval notation. So we look at our number line carefully and we look at our solution. We say, okay, well, my lower bound or my lowest value is 10. And my upper bound or my highest value is, wait a second, there's an arrow here. So how high do I go? Do I go to 20? Do I go to 30? Do I go to 100? Do I go to 1,000? Oh, wait a second. We're approaching infinity. If this infinity sign is hard for you to draw, turn the paper sideways and draw an 8. Right? Tricks of the trade. Exactly, Hannah. So you're going to turn the paper sideways and draw an 8, or do 2 tiny little circles next to each other. Now, I want you to notice that it's open circle on 10. Take a look at your open circle and look directly beneath it. You have parentheses, right? So when you have open circle, you're going to have open parentheses. Think of that as soft. It's swinging open. It's an open door, right? Open. We're approaching this. Now, with infinity, you also have to approach infinity. You can never close infinity. You cannot say infinity, you end here. No, that's not possible. And what I'm referring to is the use of brackets. You only use brackets if you're including the value, right? So less than or equal to, greater than or equal to, close circle, including the value by using brackets. Close the door, right? Okay, so far so good. Here is my interval notation. I'm going to label it interval notation. The next thing I'm going to do is I'm going to write my answer in set builder notation. And this part is the easiest part of them all. So with set builder notation, you have the same format every single time. So we are going to write it like so. We use braces to denote a set. That's the first thing. The next thing is, notice my variable is b. So I'm going to write b, and then I'm going to put a vertical bar. Notice in my reference table, I've written out the general form for set builder notation. So you have your braces, you have your variable, bar, and then notice what it says here, x has property p. Well, in this case, we're talking about b, and b is greater than 10. So all we do is pick up our answer and write it directly inside. That's set builder notation. For your reference, I would like to interpret this so that you know what set builder notation is actually saying. So our answer here, our solution says the set of all elements b such that b is greater than 10. Let me make that sharper. So the set of all elements b such that b is greater than 10. And guess what? You're done. Those are all 4 parts to solving a linear inequality. Let's do it again. Not bad, right? Let's do it again. Number 2, we have negative 7m plus 2m minus 15 is greater than or equal to 26 divided by 2. Okay, first things first. Notice negative 7m plus 2m. All right, I can combine those. That'll give me a negative 5m. Then I have minus 15 is greater than or equal to, and then I don't know about you, but when I see 26 over 2, I say, oh, that's just a 13, right? It's just a 13, no big deal. Always simplify fractions whenever you can. Now we're going to go through the motions of solving. So we're going to add 15 to both sides. That's going to give me negative 5m is greater than or equal to, man, my greater than symbols are looking whack. So negative 5m is greater than or equal to 28. All right, next I'm going to isolate m. When I isolate m, I must divide by negative 5. Wait a second, I'm dividing by a negative? Oh, so because I'm dividing by a negative 5, I must flip the direction of the inequality symbol. So we go from greater than or equal to less than or equal to. Negative 5m over negative 5 is simply m. And then 28 over negative 5, that doesn't reduce, so I'm going to write it as the fraction negative 28/5. And there's our solution. Yes, exactly, Hannah. You got to switch that inequality symbol. So the next thing I'm going to do is I'm going to graph this on a number line. So let's draw our number line. And I would like you to put negative 28/5 right smack in the center. Because remember, all we did is we shifted the number line over so that negative 28/5 becomes the center. Now, this says m is less than or equal to negative 28/5. If you flip back to your previous page, less than or equal to, greater than or equal to, close circle. So now we know we should be writing over the negative 28/5. Because it's a solid line here, it's a solid circle here. Okay, solid line, solid circle. I love it. Yes, Hannah. Now, m is less than or equal to negative 28/5. Well, less than is to the left. Greater than is to the right. So less than means we're going to shade in this direction. Perfect. And there's our solution on a number line. I love it. Now we are ready to write this in interval notation. Recall with interval notation, you take a look at your visual. I've got it here. And you say, okay, what's my lowest bound and what's my upper bound? So if we look at the lowest bound, this is arrow, right? Okay, wait a second. What in the heck does that mean, arrow? So we're going to the left, right? So is it negative 50? Is it negative 100? Is it negative 1,000? Is it negative 5,000? Oh, it's negative infinity. So Hannah's suggesting that what's happening here is that we have our negative infinity, and what we're going to do is we're going to put a parentheses around the negative infinity because we can't close it. We cannot say infinity you end here. But what Hannah is also pointing out is that our upper bound, which is negative 28/5, we are including. So it's a closed dot, so it's closed bracket, right? So think of this as like really strict and rigid. It's like a closed door. So we're open here, ah, la, yeah, great. We're approaching negative infinity. Then bam, here we're including the negative 28/5. So we're going to close that using a bracket. Okay, excellent work, Hannah. So here's our interval notation. Interval, smallest to largest, right? That makes sense. And then lastly, we want set builder notation. So as a reminder, set builder needs braces because we're denoting a set. Our variable is m in this case, so we write m and then vertical bar. Now all we have to do is pick up our solution, boop, and drop it right inside. So this whole thing, m is less than or equal to negative 28/5, we're going to put right here. So m is less than or equal to negative 28/5, and voila, that is set builder notation. Cool, right? Your turn. I would like you all to do number 3. Be super careful about how you interpret this. Read it very carefully. I'm saying that for a reason. 41 is greater than negative 17 times p plus 3 minus 4 times p plus 2. Let's see what you got. Good luck. Okay, let's take a look. So the first thing we're going to do is we are going to distribute this negative 17, and then we're going to distribute the negative 4. So we have 41 is greater than negative 17 times p is negative 17p, and then we have negative 17 times 3, which is negative 51. Then we're going to distribute the negative 4. So we have negative 4p, and then negative 4 times 2 is negative 8. So Doc, let's take a look at why we would kind of go through that process. So let's check it out. We are now going to clean up, right? We're going to combine like terms. We have a negative 17 and we have a negative 4. So we're going to combine those two to give us negative 21p. And then I have negative 51 and a negative 8, which is going to combine to give me negative 59. And this is greater than, or excuse me, 41 is greater than the rest of this linear inequality. Now, we have to isolate my term that has p. So I'm actually going to bring over the 59 so that I can combine like terms. Notice those cancel. And then, exactly, we combine like terms. So we've got 41 plus 59, which is 100. So 100 is greater than negative 21p. Now, we have to isolate p. So we're actually going to divide by negative 21. When I divide both sides by negative 21, notice I'm dividing by a negative, which implies the inequality symbol must flip directions. So 100 over negative 21, that actually doesn't reduce. So I'm going to leave it the fraction negative 100 over 21. And then negative 21 divided by negative 21 is 1, and 1 times p is p. So there's our solution. Now, here comes the tricky part. We know that my critical value is negative 100 over 21. So I'm going to write that right smack in the center of this number line. The next thing I notice is that it reads negative 100 is less than, negative 100 over 21 is less than p, which implies open circle. Now, here's the thing that trips some people up. When we read this, negative 100 over 21 is less than p, what this actually says is that p is greater than negative 100 over 21. Don't you agree? If negative 100 over 21 is smaller than p, then p must be greater than this number. And if p is greater, then we're going to shade to the right. That's the tricky part. That's why I included this problem, so that you can see something like this at least once. And then that'll help you to interpret how you draw it on the number line and then your interval notation. We are now ready for interval notation. We always look at our number line, we look at our shaded region, we say lower bound, upper bound, or lowest value, greatest value. So your lowest value is negative 100 over 21, and your greatest value, implied by the arrow, is infinity. We're going towards positive infinity, right? To the right, you're growing larger and larger, so you're approaching positive infinity. To the left, you're growing smaller, or you're getting smaller and smaller, so you're approaching negative infinity. Now, because we have an open circle on negative 100 over 21, we have open parentheses, right? It's swinging open. You're approaching negative 100 over 21. And then same thing with our infinity. You can't close it, so we're going to use parentheses in this case. Again, keep labeling these until it becomes super easy and you know exactly which is which. That's one of the other things I've seen. I've seen students accidentally mix up set builder and interval notation. With this practice and writing it again and again and again, you'll never forget it. Next, we need to write out set builder notation. So we have our braces. Our variable is P, so P and then the vertical bar. And then all you're going to do is pick up your answer and throw it right inside. So we have negative 100 over 21 is less than P. And that is set builder notation. Excellent work, everyone. Very, very nice. I'm really glad that you're taking a couple extra seconds to think about what those statements are actually saying. Very nice, Kayla. Excellent work. Okay, now take a look at number 4. What we're seeing here is something called a compound inequality. That means essentially that we're solving two inequalities at the same time. Now, there are resources out there. That's okay, Kayla. I knew what you meant. There are resources out there that suggest that you should split this up into two. And that's fine, Doc. No worries. You should split it up into two inequalities and then solve and then put it back together. I kind of disagree with that. I think that you are all more than capable of solving this compound inequality as a compound inequality. And I'm going to show you exactly how to do that. The first one I show you is actually a little bit more complicated than your regular, blah, blah compound inequality because you already know how to do this math. So I want to prove that to you by showing you something that you are capable of solving. Now, all you have to do is keep in mind is that you are solving two inequalities simultaneously, okay? So carefully watch everything that I'm doing so that it makes sense. And I'm betting anything that you're going to be just fine. That you're going to see it and be like, yep, that I get it. That makes sense. So let's take a look. So negative 10 is less than 12b minus 3 over 2 is less than or equal to 8. Now, one of the first things we learned a long time ago was that when we have an equation with fractions, that we can multiply by our lowest common denominator to cancel fractions. Do you remember that? I'm pretty sure you all do. So the first thing we're going to do, and actually I'm just going to rewrite the problem so that it's easier to see. I'm literally just spreading this out a tiny bit so that it's easier to visualize, it's easier to see exactly what's happening. My LCD in this case is 2, right? It's the only thing in our denominator. So what I'm going to do is I'm going to multiply every term by 2, just like I've done in the past, right? You are no stranger to using this technique. 2 times negative 10 is negative 20, less than. We recall that by multiplying by 2, our 2's are going to cancel, and that leaves us with simply 12b minus 3. And then we have a less than or equal to 2 times 8, which is 16. Awesome. Now, when we are solving this compound inequality, our goal is to always get our variable by itself. So I start off by saying, I want 12b alone. 12b is currently attached to negative 3. That's a problem. So if I were to cover up this side and I said, well, you have 12b minus 3 is less than or equal to 16, you would say, I know how to do this. I would add 3. And I would say, yes, you're totally correct, right? But what if I covered this side and it reads, negative 20 is less than 12b minus 3? You would say, oh, I would add 3. And I would do that to both sides. Well, guess what? You're going to do that exact thing, but to each of the sides simultaneously. Just like I said before, you are solving two linear inequalities at the same time. So we have negative 20 plus 3, which is negative 17. Bring down your inequality symbol. Bring down 12b. Cancel your opposites. Bring down your less than or equal to, and then 16 plus 3 is 19. So far, so good? Next step, we must solve for b. So again, if I covered up this side of our compound inequality, you would say, all right, 12b is less than or equal to 19, which means if I want to solve for b, I must divide by 12 on both sides. And I could not agree more. If I cover up the right-hand side of this compound inequality, you would do the same thing. If negative 17 is less than 12b, you would definitely divide both sides by 12. So that idea does not change. So we're going to write our solution. Negative 17 over 12, that doesn't reduce, is less than, make sure you bring down your symbol, b, you always need that variable in the center, is less than or equal to, and then 19 over 12. If you have solved your compound inequality and your variable is not in between the two inequality symbols, you did something way, way, way wrong, okay? Notice where b is with respect to both of these inequality symbols. It's in the middle. Leave it in the middle. You're just trying to isolate it. Okay, we are now ready to draw our number line. This time I have two critical values. On the left, I have a negative 17 over 12, and on the right, I have a 19 over 12, right? This number is smaller than this one. A negative number will always be smaller than a positive number. Next, I need to decide open or closed circle. So negative 17 over 12 is less than b. Less than open circle. And then b is less than or equal to 19 twelfths. Less than or equal to solid circle. So let's fill it in. Now you're probably wondering where you should shade. There are a couple ways to think about this. The first way to think about it is where b is in relation to these two values. b is right in the center of these two values, but that's because of what it actually says. So I'm going to read this to you, and I want you to think about this carefully. Negative 17 over 12 is smaller than b, but b is smaller than 19 twelfths. So wherever b is, negative 17 over 12 is smaller than b. So b is somewhere here because it's bigger than negative 17 12. But we also know that b is smaller than 19 12. So we're actually shading right in the middle. So that's exactly correct. So when Hannah suggested they're going towards each other, you're totally right. So that's the middle of these two. Perfect. Now that our solution is accurately represented on our number line, we're ready to write our interval notation. Interval notation is always left then right, so lower bound, upper bound. My lower bound is negative 17 over 12, comma, my upper bound is 19 over 12. Notice I have an open circle around the negative 17 12, so that's going to be a parentheses. And then notice I have a closed circle on 19 12, so that's going to be a bracket. So let's close that. And voila, that is your interval notation. Not bad, right? So with a compound inequality, it really wasn't any different. We just had two critical values instead of just one. And then lastly, let's write our answer in set builder notation. So we have our braces. Our variable in question is b, so it's brace b vertical bar. And now I just want you to pick up the entire solution and write it directly inside. So negative 17 over 12 is less than b, which is less than or equal to 19 twelfths. And you can call it a day because you have just completed solving this compound inequality. Perfect work. Very, very nice. Okay, that was your introduction to a compound inequality. I think you're ready to try one on your own. So go ahead and take a look at number 5. We have negative 7 is less than 4y minus 7 is less than 14. Go ahead and take 2 minutes to solve this. And when you're done, all I want in the chat is your interval notation. Let's see it. And just like that, you have solutions, and I love it. So let's check it out together. First things first, we obviously want to isolate our variable. So I'm going to add 7 to both sides because I have two inequalities that I'm solving simultaneously. Notice I had negative 7 plus 7. That gives us 0, and that's okay. We actually need to include, oh, very cool, Hannah. We definitely need to include the 0 here because it's a placeholder, right? Imagine if we just left that blank. That would be really weird. So bring down your 4y. These two are opposite, so they cancel. Less than, and then 14 plus 7 is 21. Next, we need to isolate y, so we're going to divide each term by 4 to isolate our y. 0 divided by 4 is still 0, is less than 4y over 4, which is y, and you're in great shape because you wanted your variable in between the two inequality symbols. And then we have 21 over 4 because that simply just does not reduce. So we go ahead and draw our number line. We have 0 to the left and 21/4 to the right. Notice that both of my symbols are less than, so we're going to have open circles for each of these. 0 is smaller than y, but y is smaller than 21/4, so that means we're right in the center, right? So if 0 is smaller than y, then that means y could be 1, 2, 3, etc., as long as y is smaller than 21 over 4. And if you plugged in 21/4 into your calculator, that's 5.25. So y is somewhere in between 0 and 5.25. Okay. Next, we write our solution in interval notation. So left, right. So left is 0, right is 21/4. We see open circles for each of these, so parentheses in both cases. And there's my interval notation. Lastly, I want to write my set builder notation by using braces, of course. I then also note that my variable in question is y. So I'm going to go ahead and write y and then the bar. And then all I have to do is simply write my solution inside this region. And I'm done. Voila. Very nice. Okay, what I'd like you to do, we do have 5 minutes, and I think you are fast enough to complete number 6. Give this a shot. 12 is less than or equal to 3m plus 2 divided by 6, which is less than 15. I'm going to give you 2 minutes. Honestly, I think that's all you'll need. Let's see it. Excellent work. So it looks like Hannah produced a solution, and her classmates thought, yes, that's perfect. I agree with that. So, yeah, and I love that you've had this experience in the past because it really does help now. And it's just so great to see it with fresh eyes, right? So the first thing we're going to do is we're going to multiply every term by 6. So hopefully that isn't too cluttered. So 6 times 12 is 72. That's less than or equal to. Notice your 6's are going to cancel. So you have 3m plus 2 is less than, and then 15 times 6 is 90. The next thing we're going to do is we're going to subtract 2. Remember, we're going to do it to each side because we are solving a compound inequality. So that leaves us with 70 is less than or equal to 3m, which is less than 88. Next, I'm going to divide both sides by 3. And I cannot reduce a 70 over 3, so I'm going to leave it as such. This becomes m. And then 88 over 3, same thing. I can't reduce it, so I'm going to leave it in fraction form. Next, I am ready to write my solution on a number line. So I have 70 over 3 to the left, 88 over 3 to the right. 70 over 3 is less than or equal to m, so definitely close circle here. And m is less than 88/3, so open circle here. And we know from experience that we're shading right in the center. If these inequality symbols were facing the other direction, then we'd have to do some real analysis here, right? Then we have to think about it, we have to break it down, figure out what it actually says. But because we are familiar with this order, 70/3 is less than or equal to m, which is less than 88/3, we know it's right in the center. In interval notation, our lower bound is 70 over 3 and our upper bound is 88 over 3. So because it's closed circle on 70/3, we put a bracket here. And because it's open circle on 88/3, we have a parentheses. And that's interval notation. Lastly, we want to write our set builder notation, so we need braces to do so. Our variable in question is m, so m with a vertical bar, and then we pick up our solution and write it directly inside the braces, and that is Set Builder. There is one more problem here, and actually what I'd like you to do is take number 7 home with you, complete that, and when I scan my notes, you'll see the solution there. But tomorrow I want to go right into graphing linear inequalities, or excuse me, on Monday. So this reads, negative 52 plus 22 over 11 is less than or equal to negative 2 times 4n minus 5 plus 10. And that's it. So we have just spent this time solving linear inequalities and compound inequalities. So on Monday's class, we're going to get into graphing linear inequalities. So make sure you bring something like a colored pencil or not a Sharpie because it'll bleed through your paper, but maybe a highlighter or something like that, or a different colored pen or pencil, whatever. All right. Enjoy your weekend. Stay safe. Bye, everyone. Have a fantastic weekend.